So this is the first of 6 different kinds of word problems that we're going to work through. And this one is often one that I think that students generally have a better time with because we're somewhat used to dealing with percentages, with sales tax and different applications that way. So in the percent problems, I'm going to give us a way of sorting our information that will help us develop our let statement and sort our information so that we can build an equation. And so this is going to be my strategy. And when you know these intuitively, you don't really need the strategy. And when they get harder, that's when you need the strategy to set them up. So in percentage problems, I'm going to say that there's often 3 different parts. There's actually a fourth part because it's always over 100. So if I'm reading a word problem and I see a percentage in it, then I write out this square. And I'm going to use this square to fill in pieces of information and sort it out so that I can build an equation. So in these 4 quadrants, there's going to be very specific things. Always 100 down here in the bottom right-hand corner and the percentage up top. Now, the other numbers are going to get sorted up into this box up here, sometimes called the amount, and this box here, sometimes called the base. The other words for amount and base, this is often the part, and this is the whole. This is sometimes the smaller, and sometimes the larger, but only for percentages less than 100. So I'm going to put those in quotes because it's not always the case. And there's another little piece of information here that that it's in the grammar. So oftentimes it's the word is attached to the number that goes to the A spot, and the word of is attached to the number that goes into the B spot. And it takes a little bit of practice to sort these out. So we're going to practice sorting out these ones in ones that you know. So 5 is 50% of 10. We know that that is true, but let's practice sorting that out. So it's a percentage problem. It's always over 100. It's going to be 50%, right? 50 over 100. And we did that back in our intro chapter when we were doing percentages and decimals. And then it's 5 is 50% of 10. So it's is and the 5 and the of and the 10. Now, it's not to say that every word is and every word of is connected to these words because we have grammar that gets a little more complicated than that, but it does help us sort out our information sometimes. So the next one, if we were to just practice this sorting of information, as soon as I see a percentage, I put 100 there. I'm going to put what the percent is up top, and then it's of 480, so that goes down below, and it is 240. And that just gives us like a starting point, a place to start understanding how this information is going to get sorted. So we haven't done any that involved solving. This was just sorting of information. We have all the parts. So these aren't really problems. They're just examples that illustrate how we put the information into this funky little chart. What we do with this funky little chart is how we're going to solve things. So let's try these ones down here. So it says solve these. What is 75% of 360? And you might be able to do this other ways, but I'm just asking you to humor me. And let's fill in the charts and see if we can use it. Because again, oftentimes when you know the answer, that's fine, but we were working on strategies so that you can get to the answer. So this is the chart that I use. The 75 is going to go over the 100, and it says of 360. So 360 is going to go down below. I don't know what is 75% of 360. So now that I have my chart, this actually counts as my let statement. And we're going to use this chart to make our equation. We're going to set it up as if they are equivalent. So this is my equation. This is my second step. And I've used this chart to build this equation. I know that these two things are related as far as ratios go. So when you solve for x, you can clear denominators, but more often people have learned cross multiplying. So you multiply top times bottom. And so it's x times 100, so 100x, and then that equals the bottom times the top. And what's not written out in these words is that it's of the two different ratios or fractions here. So it's 360 times 75. Now we want to solve for x. And so now we have this equation where you would divide both sides by 100. And you can do this now in your calculator. You can solve for x because x is equal to 270. So let's try the ones down below. Oh, the spacing on these got all wacky. Sorry about that. I'm going to do this one here, then I'm going to do that one, and then I'll do this one down below. Okay, so we're going to use our chart to sort our information. 32 is what percent? So that's what I don't know, 128. So I've set up my chart, sorting my information. I'm going to have 32 over 128 equaling x over 100. Top times the bottom, write it on one side, bottom times the top, and then solve for x. Oftentimes people are coming with some memory or understanding of this already. In this case, we get 25. Let's try two more. Sorry for the spacing. I don't know what happened on this. Okay, so we're doing a percent problem. I know that 100 goes down there. I don't even have to read the question other than to see there was a percent in it. It's a 5%, and it says 84 is, so the 84 is going on top, 5% of what number? And so the x is down below. That's what we're going to use as our let statement, and it's also going to allow us to build the equation that we're going to solve. So we'd have top times the bottom, write it on one side, bottom times the top, and write it on the other side. Divide out to solve for x. And in the second example, awkwardly squished in here, I get that x equals 1680. So you've covered all three parts of your word problem. You've got a let statement, you've got an equation, and you've got a final answer. The last one, setting it up with the is and the of cues, writing it out as an equation, and then solving for x. Using your calculator, for the answer. So these ones illustrate the mechanics of my proposed strategy on percentages. I do know that they're not always possible or not always necessary for everyone, but please do try and illustrate, what is your variable that you've defined? What's the letter representing? What is the equation? What's the math that you're doing to get to your answer? And then clearly state the number that answers the question. So we've got one down here and then a number on the other side of this page. This one says that in a shipment of 250 parts, 40 are found to be defective. What percent of the shipment is in good working order? So we're going to, right off the top, start with the chart. It says of 250, so that's down below, 40 are found to be defective. X is up here. Now, what is X representing? Take a look at this. It's the number, or the percentage that are defective. We're going to come back to that so when we give our final answer. So we've got our X let statement. We can turn that into an equation pretty easily. We're going to solve for X. top times bottom, bottom times top, getting x all by itself, we get that x equals 16. Now, in order to answer this question, we have to make sure that we've kept track of our x value carefully and we're reading the question carefully. It says, what percent is in good working order? So a bit tricky. It would be 100 minus 16, right? Because these ones were the bad ones. What we're going to be left with then are the good ones. And so we'd get a final answer of 84, or 84% are good. And again, it's not smiley face, sad faces that's your answer, but it illustrates that understanding. And so be intentional with what X is representing and be intentional with how you're answering your question. The middle of this is probably the easier part for you. I'm going to go through these ones. Oftentimes people have an easier time with these percent problems, but I'll try and illustrate how these ones go. So the first one here, arriving in Portugal, Nicholas exchanged $500, we'll say that's Canadian, and received 382 euros for that. What exchange rate did he receive? Okay, so we're looking for the rate. We know that's over 100. Now, what we do with these other numbers. So we know that he got 382 out of his $500, right? So we've got our X statement. We can set that up into an equation, basically the same thing, but with the equal to sign in it. Solving for X, oftentimes I just do this on my calculator. So I've been writing it out on all of these, but I take this times that divided by this. If you like to write it out, then go ahead and take the time to write it out. X equals 76.43%. So what we're saying is that that is the rate that he got. So he got 76.43 euros. I always forget the euro sign. For 1 Canadian dollar. In 5 minutes, I'll remember what the euro sign is. Okay, so another one with percentage here. This is on investments. So Dalmeet borrows $10,000 for a year at 11.49% interest. How much interest will she pay? Okay, so let's just see. I like writing this down because I don't even have to think too much about where the preliminary things go. So this is going to be how much her base is, right? That's how much she's borrowing. We want to know how much the interest is she's going to charge. And so X is representing the interest. And you can write that out as a sentence, but I'm fine if you do the thinking and just put it in the chart. So we've got our equation. And honestly, sometimes people just write out the chart and call that their equation too. So we'd have top times the bottom and bottom times the top, or 10,000 times the 1149 divided by 100. If you're just doing that in your calculator, we get 1149. So this is the interest. So she's going to have to pay $1,149 in interest. And you might have known how to do that one intuitively, but again, we're trying to break these down into a process so that if you don't know the answer, you have a way to get there. So lucky you, you have $5,000. Fantastic. I don't know how you got the $5,000, but that's awesome. And you're going to invest it for 1 year at 8.5%. How much interest will you earn? Well, that is going to be like how much Dalmeet. Oh, that's how much you have. And so again, the X is going to represent the interest. And so setting it up as the equation and doing the math on it, either showing everything out or doing it on your calculator, you get that X equals 425, which means that you, will earn $425. Couple more here. A state has a 7.25% sales tax. So we know it's going to be a percentage one, and we know that the percentage that we care about is 7.25. If an iPod is listed, iPod, who even uses those anymore, $2.99, things get dated fast. How much will it cost after the sales tax has been added? So even just thinking about what the X is, that's going to be the tax, right? After we get our X value, what are we going to have to do with that to get to the final price? You're going to have to add that tax onto the original purchase price, because that's how you figure out what you pay for something, right? So writing this out as an equation and solving for X, and then finally answering the question. So in this, you get a mark for your let statement, you get a mark for your equation. You don't actually get a mark for this, maybe a half mark, but the final mark you get is for the final answer. So your final answer would be the cost plus the interest, or not the interest, sorry, the sales tax. This would be the final price of the thing you're buying. Okay, one more just to take this a little bit differently here. And there's a couple ways of doing this one. So this one might be something that you get to the answer in a different way. So this one is a question that 3 out of 4 audience people left a theater unhappy. We've got, no, sorry, 3/4. So that would be 75%. That might be one way of doing this. If 87 patrons walked out, how many were there originally? So we don't know the whole, but we do know the part that we're unhappy, right? This is going to allow us to solve for how many there originally were. So X is going to give me 116. So there were 116 people in the audience. So that's the most likely way, given the way that I've been doing these ones. The other way you could do this is it's 87 over X, and it's 3/4. That's the same as 75 over 100. So that you don't have to do it this way, but this is an alternate way you could set it up and also get to the right answer. So like I said, the percentage problems are usually something people are pretty comfortable with, and it's a bit of a stretch to make you show your work in all 3 sections, but we will keep building on these. And maybe for the ones that you couldn't find the answer, it gave you a strategy that could allow you to work through the problem.